let's go over this review here. Hopefully this won't take too long. It's only 12 questions. Okay, the test tomorrow is going to look very similar. No, I'm not that nice.
You can change the numbers.
I'm going to change some numbers. Alright, so let's just go through these. Okay, the first two problems were factoring. The first thing we always look for is a GCF. Right? I've got p cubed minus p squared minus 2p. I can take a p out of all of those, and I would be left with p squared minus p minus 2. Then I can x factor this. Right? So I'm looking for two numbers that multiply to negative 2, that add to negative 1. Well, that's going to be negative 2 and positive 1. So since my leading coefficient, the number in front of the squared term, is 1, I can go straight to factors, meaning that this will just be p minus 2 times p plus 1. That's it. Okay. Now, a lot of people in their final factored form are still forgetting to include that factor of p. Right? That factor of p that we took out up here doesn't go away. That still needs to be included in our final factored form. Right? And number 2, okay, again, first step is to look for a GCF. Between 3, 8, and 16, I don't think there is a GCF. So go straight to x factoring. So here, my leading coefficient is not 1. So remember, we need to take a times c. So 3 times negative 16 would be negative 48. And my b term is 8. So I want two numbers that multiply to negative 48 that add to positive 8. What do you think? Seven times 7 is 49. So what do we do if we can't figure it out right off the bat?
It's going to be 4 and 12.
It's going to be 4 and 12, yeah. Right. But if we can't figure it out right off the bat, then we would just come over here and start listing out numbers that multiply to 48. Right? So I'd have 2 or 1 and 48, 2 times 24, 3 times 16, 4 times 12, and we just keep listing them out until we see a pair that will add or subtract somehow to this number. So with 12 and 4, I could say 12 plus a negative 4 would get me positive 8. So now, since my leading coefficient is not 1 here, I have to factor by grouping. So what that means is all I'm doing for my first step is turning this 8x into 12x minus 4x. So I have plus 12x minus 4x minus 16. Right? This 3x squared stays, this minus 16 stays. All I'm doing is splitting this 8x into these two factors that we found. Now we group. Okay, group the first two, group the second two, and look for GCFs. So between 3x squared and 12x, what GCF can I take out?
3.
We just did the cons. Alright, sweet.
3x.
3 for the first one and 4 for the second.
Yeah, so I can take a 3x. What am I left with then?
X plus 4.
Plus 4. And then I've got negative 4x minus 16. So if we take out a 4, if we take out a positive 4, I would be left with negative x minus 4. So what we probably want to do, if we want to make that factor look exactly like this, I want to take out a negative 4. So if I take out a negative 4, this would become positive x, and this would become positive 4.
Okay. Let's do 3x, x minus 4 in one, and then x plus 4 in the other one.
Okay, so my final factored form looks like this. 3x minus 4 times x plus 4. I've also seen a lot of people stop here. Okay, that is not the final step for a factor by group. This is. Okay, we should have two binomials like that. for a factoring problem.
That's good for that.
All things. Questions?
Being recorded.
Yes. All right. So then we got into some simplifying and multiplying and dividing. So to simplify rational expressions, what do? This first one, I get x squared minus 19x plus 90 over x squared minus 2x minus 8. Yeah, factor everything we can. Right, x factor. So both of these, my numerator and denominator, will have to x factor. So the first one, I'm looking for two numbers that multiply to 90 that add to negative 19.
It's 9 and 10. But they're both going to be negative.
Right. They will both be negative. Negative 9 times negative 10 is positive 90. Adding them, we would get negative 19. Now, my leading coefficient is 1, so those are my factors. Right? X minus 9 and x minus 10. Then let's x factor the bottom. So I want two numbers that multiply to negative 80 that add to negative 2.
8 and 10 wouldn't work. But 8 and 10 would work.
Both positive, both negative, one positive,
I
one
think
negative.
one.
Which one?
It's going to be
The bigger one. Yes.
So we want them to add to a negative 2.
Oh, yeah.
Right?
Yes, right.
So yeah, you're making 10 negative here. So again, my leading coefficient was 1. That means these are my factors. So x plus 8 and x minus 10. Now what do? Yeah, if there was a GCF, we would have done that first.
Oh, you can take out the x minus
Alright, cancel out any common factors. So, we are just left with x minus 9 over x plus 8. And we also need to state the excluded values, right, or restrictions. So, this is the final simplified version. We've done the simplifying part, but now we need to state our excluded values. So that's x cannot equal. Remember, those come from each factor in the denominator. So, in my denominator, I have two factors. Right? Right, so we want to think about what values would make each factor equal to 0. So negative 8 plus 8 would be 0. So that means x cannot be negative 8. And positive 10 would make this factor equal to 0. So x cannot be 10 either. Okay, remember, even if we cancel the factor out in the denominator, we will still get a restriction from that. Okay? So we get restrictions from both of these. So this whole thing, simplified fraction, and my restrictions is my answer. Okay with that one? Alright, how about the other simplify one here? What can I do here? I got a GCF. So in my numerator, what GCF can I take out?
You can do at least 2 of the top and bottom.
Yeah.
But you can do more off the top.
Yeah. Right. I think we can take a 4n out of the top, and what would I be left with then? So if I take a 4n out of 28n squared, remember that means we're dividing. So what's 28 divided by 4?
It's going to be
7.
7. And then n squared divided by n?
26.
Yeah, so we'll have 7n, and then 24n divided by 4n, we would have 6. Okay? Now in the denominator, what can I take out of both 8n squared and negative 20n? I can take a 4 out of the numbers, and I can take an n out of both of those as well. Okay? And then what am I left with?
2n minus 5.
2n minus 5. Now what? Yeah, cancel whatever we can. I've got a 4n and a 4n, so I can get rid of both of those. That's about all I can do. Right? So my final simplified version is 7n plus 6 over 2n minus 5. Then we need our restrictions. So n cannot equal. So I've got two factors again in the denominator. So from this first factor, 4n, 4 times what? 4 times 0 would be 0. So I can't have 0. And then this one, 2n minus 5. Yeah, that one is one of those ones where it's difficult to just look at it and know what the value is. So we can come off to the side here and say 2n minus 5 cannot equal 0 and solve that little equation. Yeah. So add 5, we get 2n cannot be 5. Divide by 2, we get n cannot equal 5 halves. Okay, so my two restrictions then are 0 and 5 halves. You okay with those? Alright, then we had some multiplication and division. So, in the multiplication problems, it's basically just one big simplification problem, right? So in this first one, it's already all factored for us. So I can just start canceling things out, right? Because we're just saying this is one big fraction. So I can cancel out the x plus 7s, I can cancel out the x minus 5s, and I'm just left with 6 over x plus 4. Then our restrictions. So, same thing. All the factors in the denominator are where our restrictions come from. So, from this factor, I would say x cannot equal
Negative 4.
negative 4. Okay, what value of x would make this factor equal to 0? Negative 4.
And then negative 7.
And then negative 7. Positive 5. Yep. So 3 restrictions out of this one. And the next one, we got a little bit of factoring to do. Actually, a lot of bit of factoring to do.
Actually, every single one.
Every single one. What? Yeah. Prepare for the test tomorrow.
I'm gonna be good.
All right. So I have to factor all 4 of these here in this problem. So let's just start up here. So I want two numbers that multiply to positive 3 that adds a negative 4. What numbers multiply to positive 3 and adds a negative 4? Negative 3 and negative 1, right? And in all of these, my leading coefficient is 1, so I can go straight to factors for all of these. So this first one will be b minus 3 times b minus 1. Then let's do the denominator here. So I want two numbers that multiply to positive 2 that adds a negative 3. What numbers would multiply to positive 2 and adds a negative 3?
2 and
2 and 1. They'll both be negative. Okay. Negative 2 plus negative 1 is negative 3. Negative 2 times negative 1 is positive 2. So this will be b minus 2 and b minus 1. Well, let's do these two then. So up here, I want two numbers that multiply to negative 2 that adds a negative 1. Numbers that multiply to negative 2 and add to negative 1. 2 and 1. Which one would have to be negative? Negative 2. And negative 2 plus 1 is negative 1. So this will factor into b minus 2 times b plus 1. And then finally, this This bottom one, I want two numbers that multiply to 21 that adds a negative 10. What numbers will multiply to positive 21 and adds a negative 10?
7 and 3.
7 and 3. And they'll both have to be negative. Okay. So this will be b minus 7 and b minus 3. So now that we have everything factored, we can think about this as one huge fraction and just start canceling things out. So I see b minus 1s, I see b minus 2s, and I see b minus 3s. So I'm just left with b plus 1 over b minus 7, and then we need our restrictions. So restrictions come from every factor in the denominator. So I would get positive 2, positive 1, positive 7, positive 3. I have 4 restrictions for this one. Alright. We okay with this one? Alright, then on the back, had some division. Alright. So for division, division is really similar to multiplication, except, first thing we have to do is flip the second fraction. So I'm just going to rewrite first fraction and change this to multiplication and take the reciprocal of this second fraction. So the first step is just rewrite this as a multiplication problem. Now this one's already all factored for us, so I can just start canceling some stuff out. So I can cancel out the x plus 8s, I can cancel out the x plus 3s, and I can cancel out the x plus 7s. So all I'm left with then is x minus 1, and that is in the numerator, so it would just be x minus 1. And now the restrictions come from anything that was ever in a denominator. Okay, so anything that was ever in a denominator would be this, these, and these factors, right? These factors were the denominator up here, right? So I'm looking at these to get my restrictions. So first, negative 3, negative 8, negative 7, then up here, we would get negative 3 and negative 7 again. Okay, so I don't have to rewrite them. Okay, but we do have to check those. Okay, so this is my whole answer for number 7. Number 8, again, first step. Yeah, what's up?
What if you don't flip? Aren't you supposed to flip the second problem?
Mm-hmm.
What if you don't flip it? What do you get? What happens?
Well, then.
I forgot to flip it.
Well, so if you forget, if you don't flip it, then we wouldn't have been able to cancel out the x plus 8s because they're both on the top, and the x plus 3s because they're both on the bottom. Right? So that is a really important part of division. Yeah, flipping the second one. All right, so on this one, okay, again, first step, I'm just going to rewrite this flipping. So 9k plus 36 over k squared minus 2k minus 24 times k squared minus 14k plus 48 over k plus 2. So now that we have our multiplication problem, we want to factor everything we can. So let's start up here with 9k plus 36. Is there anything I can do with that? I can factor out not a 9k.
Or no, I mean I'm saying you can factor. I'll say which one.
Yeah. We can factor this 9k plus 36. Right, so right, we can take a 9 out.
Four.
Yep. So we're left with k plus 4. So then both the denominator here and the numerator here will have to x factor. So I'll come off to the side here. Say I want two numbers that multiply to negative 24 that add to negative 2. Numbers would multiply to negative 24 and add to negative 2. One of them will have to be negative.
It's going to be 6.
6 will have to be negative. So, my leading coefficient is 1. That means those are my factors. So, k minus 6 and k plus 4. So then, let's x factor the numerator over here. So I want two numbers that multiply to 48 that add to negative 14. Numbers will multiply to positive 48 and add to negative 14.
6 and 8.
6 and 8. And they will both be negative in this case, right? And again, my leading coefficient is 1. So these factors are just k minus 6 and plus k minus 8. And then nothing I can do with k plus 2. Now I have everything factored. I can cancel stuff out. So I've got these k plus 4s, k minus 6s. So I'm just left with 9 times k minus 8 over k plus 2. And we need our restrictions. So k cannot equal, we're looking at anything that was ever in a denominator, so that would be this, 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 and this, right? This was the denominator up here.
Positive 6.
So positive 6.
Well,
Negative 2 from this one. Negative 4 from that one. And 8 from that one. Nice. Feel okay with these? Alright, so the last few then are the new stuff, okay, that we have never had a quiz or a test over. So adding rational expressions and then solving rational equations. So in all of these, we do have to do some addition. In order to perform addition, I need to get common denominators, right? So in number 9 here, if I look at my denominators, 5 and 3y, there are no factors in common. Right? So to get common denominators, what I'm going to do is multiply this fraction by the denominator over here, by 5 over 5. And then I'll multiply this one by 3y over 3y. So when I do that multiplication, 3y times 3x would be 9xy. And then this would be 3 times 5 is 15y. And over here, I would have 10x over 15y. Now that I have common denominators, I can add my numerators together. 9xy and 10x are not like terms because they don't have the exact same variable. So I can't really do much with them. I would just write it as 9xy plus 10x over 15y. Number 10 is pretty similar. Okay, again, my denominators don't have any factors in common. And remember, we're thinking about this n plus 1 as its own factor. Right? N isn't a factor and 1 isn't a factor. N plus 1 is an entire factor. Okay, so I would have to multiply this one by n plus 1 over n plus 1. And then this one by 2 over 2. So when I do that, over here, I'm distributing the 2 to both of these terms. So I'll have 2n minus 6 over, and we can just leave the denominator factored. Then over here, I'm again distributing this 6n to both of these terms. So I'll have 6n times n is 6n squared. 6n times 1 would be 6n over 2 times n plus 1. Now I have common denominators. I can add my numerators together. So to do that, I want to combine my like terms. The only like terms are going to be the n's, right? 2n plus 6n. So there are no other n squared, so I can say 6n squared, and then 2n plus 6n is 8n. Negative 6 plus nothing would be negative 6, all over 2 times n plus 1. Okay with that one? All right, then the last two are just solving rational equations. So on this first one, you remember the first step is just to look at the side that has addition and make those into one fraction. To do that, I need to get common denominators. So here, my denominator is k squared. Here it's 3k squared. So to make those denominators look the same, I would multiply this first fraction by 3 over 3. So I'm not doing anything on the left side here. Then I'll end up with 3 over 3k squared plus k plus 6 over 3k squared. So now I can combine my like terms in the numerator. Bless you. So 3 plus k plus 6. The 3 and the 6 are like terms, so I would get k plus 9 over 3k squared. So once I have one fraction equal to one fraction, then I can cross multiply. Right? So cross multiply, I'm going to have k times k plus 9. So I'll write that like that. And that equals 3k squared times 1. 3k squared times 1 is just 3k squared. So over here then, I distribute this k through. So k times k is k squared. K times 9 is 9k. Now, my goal is to get everything on one side equal to 0. And we've talked about, we want to try to keep the coefficient in front of the highest power positive. So, my highest power is 2, or a squared term. I've got more k squareds over here on the right side of the equation. So, I'm probably going to want to move both of these terms over to the right side. So, I'll subtract k squared plus minus k squared, and then I'll also subtract 9k. So, over here, both of these will cancel out, and I'll get 0. 3k squared minus k squared is 2k squared, and then nothing minus 9k would just be minus 9k. Now, look for a GCF. So I can take a k out of both of these terms, and I would be left with 2k minus 9. So now that I have this factored, I want to take each factor and set it equal to 0. So say k equals 0, and 2k minus 9 equals 0. So this is obviously done. Here, I would add 9, divide by 2, and we get k equals 9 over 2. So remember, you do have to check to see if either of these are extraneous solutions. So I want to take both of my answers and plug them into the denominators to see if the denominators equal 0. So if I plug 0 into my denominators, do I get 0 anywhere? If I plug 0 into my denominators for k, do I get 0 anywhere? Yeah, right? If I plug 0 in for k, k would be 0. So we can't have 0 in a denominator. That means this is an extraneous solution. It doesn't work. If I plug 9 halves into my denominators, will I get 0 anywhere? No. So that means that 9 halves is my only answer. Alright. Okay with that one? Alright, then the final one. Same process. And I've got 2 terms over here that I want to add together. So I'm ignoring this side first, and I want to combine these into a single fraction. To do that, I need common denominators. So my denominator here is n, here it's n squared plus n. So I need to figure out what I need to multiply this by to make n become n squared plus n. Okay, well, if I think about n squared plus n, that's the same as I can take an n out of both of those and say this is just n times n plus 1. So if I think about this fraction here, right, or this denominator, it has the factor of n. It's just missing the factor of n plus 1. So what I can do is multiply this fraction by n plus 1 over n plus 1. So when I do that, this one will stay the same. 6 over n squared plus n equals, so here I would have to distribute this 3. So 3n plus 3 over, this will be n squared plus n, plus 1 over n squared plus n. So now I can combine these into a single fraction. 6 over n squared plus n equals 3n plus 4 over n squared plus n. Now I can cross multiply. Cross multiplying here is going to actually get a little bit ugly. Right? So I'll have 6 times n squared plus n equals 3n plus 4 times n squared plus n. So on the left side here, I can distribute this 6 and get 6n squared plus 6n. Now over here, I have a binomial times a binomial. I'll have to FOIL, or double distribute. So 3n times n squared would be 3n cubed. 3n times n would be 3n squared. Then 4 times n squared would be 4n squared. 4 times n, 4n. So now, I want to combine like terms. On the right side of the equation, I've got 3n squared and 4n squared, so let me combine those first. So that would be 7n squared. Now, I want to get everything on one side equal to 0. So, probably going to make sense to take these 2 terms and subtract them over here. So, minus 6n squared minus 6n. 6n squared minus 6n. So I end up with 0 equals 3n cubed plus n squared minus 2n. And now we want to solve this. To do that, we factor. Right? So first, I'm going to come over here and finish this. So I've got 0 equals 3n cubed squared minus 2n. First, we always want to look for a GCF. Is there a GCF that I can take out? Is there a GCF that I can take out of 3n cubed plus n squared minus 2n? I can take an n out. Right? So I can say this would be n times 3n squared plus n minus 2. Now, here, I can x factor this, right? So I can come off to the side here and say I want 2 numbers that multiply to 3 times 2 is negative 6, that add to positive 1. What numbers would multiply to negative 6 and add to positive 1?
No,
It would be 2 and 3.
that's all.
Not quite. One of them's going to have to be negative, right? Which one would have to be negative to add to positive 1? 2 plus negative 3 is negative 1.
Girl, I said 2.
Did you call me girl?
Yeah, girl.
So the 2 will have to be negative. Now, my leading coefficient here is not 1. Means I have to factor by grouping. So, I'll come over here and say this will be 3n squared minus 2n plus 3n minus 2. And I can group the first 2, group the second 2, and look for a GCF. So in 3n squared minus 2n, what can I take out of both of those? N. Right? And I'd be left with 3n minus 2.
So long.
This one is a log. This one's a long problem.
Is there gonna be like this one on the test?
That's it.
Probably not. They'll probably both look more like number 11. So here I can take a 1 out, right? There's nothing I can really take out of either of those. So my final factored form then would be 3n minus 2 times n plus 1. So I still have that n out front, right? So this will be n times 3n minus 2 times n plus 1. And now to solve, I want to set each of these factors equal to 0. So we'll say n equals 0, 3n minus 2 equals 0, and n plus 1 equals 0. So this one's done. Here, I would add 2, divide by 3, we get n equals 2/3. Here, I would just subtract 1 and get n equals negative 1. So I've got 3 answers, right? 0, 2/3, and negative 1. I need to plug all 3 of those in to see if I get any zeros in my denominator. So if I plug 0 in, well, to this one, that would be a 0 in the denominator, so that one's no good. If I plug 2/3 in, 2/3 squared plus 2/3, 2/3, 2/3 squared plus 2/3, none of those are going to be 0. So that one works. Then negative 1. If I plug negative 1 in, what's negative 1 squared? Positive 1, right? Plus negative 1. So positive 1 plus negative 1 would be 0. So negative 1 does not work either. We have 2 extraneous solutions here. The only answer is 2/3. Okay. Questions?